Now I'm introducing you to electrical installation test. First thing we need to establish is that our IR and continuity tester are functioning. So first thing you do is you actually check that the battery is in good order. The next test is a 3 ohm continuity test. Now I always suggest that if we do a continuity test, we actually test the actual bridges that you're going to be working with. Okay? Because if you know that they're continuous, you actually zero in the meter with the bridges. Okay? So I always suggest do every bridge in turn. So this might take a couple of seconds. Waiting in what, 2 bridges? 1, 2, yeah, 3. Alright, so basically we zero in the meter on each bridge. Okay? That's a reading that you don't look for. You get 1 ohm reading if you don't zero it in properly. So we're looking at a 0 reading, first bridge. So each time we zero in or move the meter dial, we should turn the button off, otherwise the internals can get damaged. So that's our first bridge. Leave that there. Okay. Second bridge, we'll try. That establishes the fact that our bridges are functioning. Okay, that looks like pretty good there. Yeah, that's pretty good. And one more. Spot on, okay? Alright, I always suggest your first bridge should always go, okay, your next step is the MEN link must be removed before you do any test, always. Okay, so one of the bridges can go on the MEN link that's removed. Okay, and our very first test is to establish that the main earth is continuous and has a reading of 0.5 ohms or less. That's always our first test. Okay, so again, 3 ohm scale. Now this bridge we can actually leave in, we can actually leave this tail in all the time, no drama. Meter on. Now we're looking for a reading. Notice I don't go to the earth clip because there could be paint or a loose fitting. We actually go straight to the earth stake itself. Now, I'm reading here 1 ohm resistance, 1 ohm. That's a fail. It's a fail. But for the sake of the exam, you write that in your report. But it's a fail. In reality, you'd have to fix that main earth before you did any other test. But for the sake of this exam, 1 ohm is a fail. We're also looking for 0.5 ohms for the water pipe bond.
Do you write in 1 ohm or greater than 0.5?
Well, exactly what you see here, you write 1 ohm,
yep.
And that is greater than 0.5, but 1 ohm is a fail. I'd be writing exactly what I see, 1 ohm. Okay, so there's 1 ohm. So both these tests fail. They should be 0.5 ohms or less. You actually should write 0.5, the exact reading you can find. Sometimes if you're near 0, you don't write 0 ohms. They do not want 0 ohms written down. So you write 0.01 ohms or less than 0.1 ohm, but you don't write 0 ohms. So once we've done the main earth and the water pipe, we then go through all the earthing in the whole installation. We never forget that the meter box has to be earthed. Okay, so in this case, I can't establish anything on the meter box. So there we have an open circuit. Now if you have an open circuit, meaning more than 3 ohms, we don't just say, oh, more than 3. We actually try it on the 500 ohm scale just to see exactly what you get, what type of reading. Again, it's still open. So you'd say greater than 500 ohms, open circuit earth. Okay, it's a fail. Let's go back to 3 ohm scale. So now we just progress from top to bottom to all the all the earthing points. So the first one here, the light fitting. Yeah. Okay, that would be a very good reading, 0.015 or less, and we confirm that reading with table 8.2 of your wiring rules. Okay, we do the other light fitting. So we look for a part where it's not connected to paintwork. Again, we write this reading down. Then we do our plug base, sorry. Okay, do our socket outlets. And each time we identify a reading, we write it down immediately, not to think and, oh yeah, maybe we can, I'll write them all down when I get to a bit of paper. As you see the reading, write them down because you can get mixed up. And now we do the actual the range plug. Okay, so that again is a low reading. Alright, just one point, if anything's plugged in to the range, you unplug it. That's a separate test. All we're doing is a installation test here. We don't include light points, light globes plugged in or appliances plugged in. It's a purely installation test. So I believe I've done all the earthing tests. Okay, so that's one part of our test gone. The next test is the insulation resistance of the whole installation. So we just take our meter off there. Now what we have to do here, when they say the whole installation, we mean bridging. Okay, your first one is a bridge between your active and neutral connection at the mains box. There. Then we have to bridge the unmetered active with the metered active at your meter panel. Okay? That's the next bridge, because we are doing the whole installation. The next point, every circuit breaker and switch needs to go on. If I leave one or two off, I'm not actually doing an IR test right through. So I actually turn all the breakers on, main switch on. The next point is every switch in the installation should be on. In fact, even the socket outlets. How do you know it's not damaged within the socket outlet itself? Unlikely, but it could be. Turn that switch on. So at this point, any test I do will give us a reading for the whole installation. The next point, we then turn our dial to 500 volt DC. Okay, we're going to pump double the working voltage to see if that insulation breaks down. So double 230, 460. So we put on the 500 volt scale. We're looking for breakdown of insulation. Breakdown. Now once you put the button on, if I connect that to earth, you see that's the reading you don't want. That is an insulation breakdown to earth. That is what I don't want, okay? We're looking for 1 megohm or greater. Okay, and basically all you need to do is put this lead on anywhere on the installation and you should get the same reading. The same reading because we're bridged everywhere. It doesn't matter where I put this. I can put it virtually anywhere and I'll get the same reading, not even back here. Because it's all bridged. If I happen to leave any breakers off, I wouldn't get that reading. And what is our reading? Our reading is a fail. In fact, it's 0.45 megs, 450,000 ohms. That's a fail. It should be 1 megohm or more. Okay, so we have a failure somewhere of insulation. Alright, we take the button off. Now we're going to prove, where is it? The first one we should be doing is the failure in the mains. To do the mains only, we have to disconnect all the other circuits out of the installation. So we've isolated all our final sub-circuits from the mains. So all I need now to do is test the mains only. That looks like a breakdown to earth there. Try the neutral. Okay, we don't settle for this now. You've got to say, okay, where is the breakdown? Because while we have bridges, we don't know whether it's in the unmetered cable, active, or the metered active, or the neutral. So basically what we have to do now is establish which part of the circuit is broken down. So to do that, we take our bridges off and we just test the individual cables. The unmetered active passes, oh, sorry. The unmetered active doesn't pass. Alright, so it's 0.45. The neutral is 200 megs, and the metered active is 200 megs. You'd write 200 megs, you don't write infinity megs. So we have the cause of this could be a tech screw through that cable, maybe in the purlins, yeah? Which probably you wouldn't have noticed if you don't test. And quite often after a test, after the electrical trade leaves the premises, you get plasterers come up and do damage. But certainly with that reading, you could blow a service fuse or whatever. It's just, it has to be repaired. But I don't stop there. It doesn't mean that I now don't do any of the rest of the installation. I need to prove that all the other parts of the installation are clear. So, with these breakers in the off position, I'm just doing the load active of, say, circuit 1, yeah, circuit breaker 1, and that's a stove, isn't it? Yeah, and it's neutral. Don't do active right through and then neutrals. Go circuit by circuit. So circuit 1 active, circuit 1 neutral. Okay, then we do circuit 2 active, and that's protected, so that would be circuit 2. Circuit 2. And circuit 3 active, circuit 3 neutral, and then the lighting one is an RCD MCB where we only need to do active and neutral on the load side. Okay, so our fault here is an unmetered active that's broken down to earth. The insulation is broken down to earth. The cable from here to the mains box, somewhere in between, there's been a breakdown to earth. Alright, that's that step. Now we write results down as we go along. The next test is polarity. Now, polarity is all about ensuring that the active is switched and the neutral is continuous. Basically that's what it is. That the actives are switched or fused and the neutrals are continuous. So with polarity is all about continuity. So we go back to the 3 ohm scale, and every now and then from time to time you can actually just prove that your meter's working. Whenever you change scales, it's a good idea to prove every now and then. So what we're doing with this is making sure that that active in fact goes to this fuse, this active to the top of the main switch, this neutral is a 4mm neutral for metering, which we expect to go to the neutral link. Our main neutral is always under the 2-screw plate here that goes back to the neutral link on the mains box, and the adjacent neutral goes back to our main neutral bar, the unprotected neutral bar. Alright, so basically it's a matter of ensuring this, that we have continuity. So you can see here, and you take that reading, whatever reading you find in the exam, you take that reading. 4 ohms, 5 ohms, we've still got continuity. It's not about how many ohms, it's about knowing that it's continuous from that point. Alright, then we can do, at this point we can do our neutral. I suggest you do from left to right, so give you a bit of sequence there. So this neutral we expect to come up here to the neutral link. We expect some continuity there. We expect continuity back to the neutral bar. And if you want to, you can prove that again. Okay. And then the final one is the active. making sure it's continuous back to your main switch. And also, if you had a hot water service here, you need to ensure that, say, your boost tail would be continuous to your main switch hot water service. Alright, once we've done the mains, we do then the individual circuits. And again, I reckon use the sequence. Don't start in the middle, start from left to right. So let's do the active first, say on the stove circuit. Stove circuit active. Okay, so what we're looking for, I don't know, is, I've got the right one too, look at that. No? Alright, I've got continuity there. Now what's happening is, look, you can see the active is continuous. It's not being switched. That's not illegal, by the way. But we just proved here that the active is not switched. So let's see what's happening with the neutral. We never neglect the neutral because that too could prove that it's switched or not switched or whatever. What's happened there is we have a switching of the neutral. Alright, so, and how you'd write that is, so neutral switched, fail, active continuous, pass, but you could say not switched, active not switched. But definitely this circuit fails because the neutral switched. Alright, notice I went active and then a neutral. You don't just go all actives and all neutrals after. Just go circuit by circuit. Alright, next one. We can do circuit 1. So we have a fault there, we note that. So circuit 1, this one, that's circuit 2, sorry. Well, that's the active circuit 2. Active switched. Looks like that socket outlet there is circuit 2 also. It's probably not a bad idea too to actually see that your circuit breaker works. And you can do that by just switching through like that, yeah? I mean, the aim is to see if you got your wiring correct, but you can actually prove that your breaker is not defective by doing that. So you can see the two actives were working okay. The next one is we go to the neutral. Its neutral is protected at this bar, yeah? So we're going to make sure we have continuity with our neutral. Yeah? All right. Make sure. All right, what's happening here? I don't seem to have a neutral there for an open circuit. We don't just sit there and say, oh, that's fine. Go to the 500 ohm scale and just prove. In fact, I can have a reading here. And what I need to do is make sure that the neutral is not switching. So just do that action again. You can see it's continuous. And for the sake of the exam, that wouldn't be wrong for you to write that reading because you're proving continuity. Remember, I went from 3 ohms to 500. And that reading is 4 ohms, yeah? So we have a neutral there. And we have a neutral there. Or do we have a neutral there? Now this, okay. We don't have any reading there. It's a very low reading, but it still passes, yeah? We still know we have continuity to that neutral. Alright, that's circuit 2. Any questions so far? No? Alright, let's do the next circuit. Where are we? Over here. Circuit 3. Circuit 3, that's the active there. No, switching the active. Now that could represent a switch in a bathroom. That's your plug base in the ceiling for the ceiling fan. for the active switch. Fine. Alright, let's try the neutral. Again, let's just prove that we have continuity there, okay? Irrespective of the switch. That's 3. And the last one is an RCD MCB for the lighting. There's your active. You can't see that. So basically, we're switching the active. I suppose while we've got that active there, we could actually go now. This is an Edison screw lamp holder. So we're looking for an active that's in the centre terminal. For the sake of the outer terminal is something that's exposed, and you can't have an active in the centre, in the outer. No, an active there. Right. Okay. See that switches. Okay. That's fine. Now we do the neutral for both. Neutral, and try to switch. I should have put that there, shouldn't I? So, irrespective, it's working, and then the neutral here. And that shouldn't affect us, fine. That's your polarity. So you go to whatever switchboard you have, that's the way to check polarity. The only point is if you have a two-way switch in a house, or three-way, you don't assume that when your switches are down that you're going to have an active continuity. You may have to try that in both positions. In fact, for the IR test, the same. So the two-way, you need to do the both positions. Alright, our last test is the fault loop impedance. Fault loop impedance is basically making sure that our circuit breaker will trip in the required time if the resistance of the installation of the earth and active is low enough for that breaker to trip in 0.4 of a second. Not 1 second or 2 seconds, but 0.4 or less. Alright, so what we do, if for example we're going to do let's do a polarity test on circuit 3. Alright, so what you have to do is put a bridge at the switchboard from earth, okay, to circuit 3. 1, 2, 3. It's always active to earth, and the brake has to be off. If these are on, or any of them are on, you're going to actually do a loop test through other circuits which you don't want. You only want to do the circuit, and so it's best to have them all off. So, and the next point is that you do on continuity scale, check it again, between earth and active here. So that reading you take, that is an RPH. If you had that switch off, you won't get that reading, by the way. So that's an RPHE value, resistance of your phase and earth together. All we're making sure is that that's low enough, according to table 8.2, to allow that circuit breaker to trip in the required time. And you record what you see here, and compare that with table 8.2, and away you go.